Welcome back to part 2 of GCP Security Best Practices and a Q&A. Previously, we've spoken about a few examples. For today, we will continue with these scenarios and we'll see how that basically help us to implement, our GCP best practices. So, again, without further ado, let's we jump into part 2. Customers need an alternative to storing credentials and plain text secrets in the source code management system. How should the customer achieve this using GCP? Basically, they're storing everything in clear text. They need to encrypt it. What shall we do? Use a cloud source repo and store secret in the cloud SQL. I don't know what is this. Nothing to do with this encryption. Or B, encrypt the secret with customer managed encryption key and store them in the cloud storage. This sort of like makes sense because you're encrypting everything and then you store it in the cloud. So the answer is B. C, run the cloud data loss prevention, DLP, nothing to do with this encryption, or deploy SCM to compute engine VM and with local SSD and enable pre-mutable VMs. Again, this does not achieve what we are after, which is encryption. So the answer is B. Encrypt the secret with customer managed encryption key and store them in the cloud. Next, for compliance reason, an org need to ensure that Inscope PCI for Kubernetes pods reside on Inscope node only. What does that mean, Inscope node only? The nodes can only contain the Inscope pods. How should you achieve that? Basically, we're talking about, how we can, use labels. So let's go through the answers. Adding a node selector field to the pod configuration to use node label and scope, which equals true. Create node pool with the label and scope and assign the true via policy, or place a taint on the node with the label and scope. True and effect node scheduler and toleration to match the pod configuration. I think this is the correct answer. And run all the scope pod in the namespace in scope PCI. So the answer is placing a tint on it. As you have a look. And the answer is placing a tint on the node with the label in scope. Equal to true and effect on schedule. Next, what are the steps taken to encrypt data using envelope encryption? Do we generate encryption key first locally? Yeah, using the key to wrap the data encryption key. So we generate the data encryption key, the DEK, locally. Then we wrap it via the key encryption key. Then we encrypt the data within the key encryption key. Then we store it and then wrap it. Or we generate the encryption key locally, then use the generate key to encrypt the key, then encrypt all the data and then store it. Or generate the data encryption key locally, sounds right, and encrypt the data with that key, okay? Then use the encryption key to wrap it, then store the decrypted data and wrap it. And last one is generate the key locally, key encryption key, then generate the data and encryption key. Oh, that doesn't sound right. So the answer, in my opinion, is C. We generate the data encryption key first. Yeah, not key encryption key, data encryption key. Then I use that key to encrypt my data. Then I use the key encryption key to wrap it like additional layer and then store the encrypted data and the wrapped key. Answer is C. Next, an org receives an increasing number of phishing emails. Seems very popular nowadays. Which method should be used to protect employee credentials in this situation? Shall we use multi-factor, strict password policy, capturing the login page, or encrypting email? It's a phishing email, so we need to encrypt the email. Simple as that. Answer is encrypting emails. Next, a website design company recently migrated all the customer site to App Engine. Some sites are still in progress and should only be visible to customers and company employee from any location. Which solution will restrict access to in progress site? Basically, uploading an HTA access file containing the customer's employee account to App Engine. Doesn't sound right. Create an App Engine firewall rule that allow access from the customer and employee network and denies all other traffic. This one sounds interesting. Enable cloud identity aware proxy and allow access to Google Cloud group that contain the customer and employee user account. Or use Cloud VPN to create a VPN connection between relevant on-premise network and company GCP virtual network. I mean, B, C, and D, they sound valid, but I will lean toward the proxy because enabling cloud identity aware proxy will allow the access with minimal, I will say, dependency. Because if you see the requirement is the website need to be visible. Yeah, we're talking about website, and you can achieve it via different method. However, there was no restriction here. It says like from anywhere, any location. Okay, so the answer is enable cloud identity proxy aware and allow access to group that contain customer and employee user data or accounts. Sorry. Next, a customer want to run a batch of processing system on a VM and store the output file in a cloud bucket. The networking and security team have decided that no VMs may reach the public internet. How we can achieve that? Create a firewall rule to block internet traffic from a VM or provision a gateway to access the cloud storage endpoint API, enable private Google access by VPC, or mount storage bucket local file system on every VM. The answer will be a NAT gateway to access the cloud storage API endpoint. Let's have a look. And the answer is provision a NAT gateway to access the cloud storage API endpoint. Next, which two implied firewall rules are defined on a VPC network? Choose 2. A rule that allows all outbound connection. Correct. A rule that denies all inbound connection. Correct. Otherwise, you can see that C, D, and E is talking about specific port, 25 connection, or a rule that blocks all the outbound connection. That's not true. A rule that allows inbound port on APT. Basically, we allow outgoing by default, and we deny all incoming. Then you need to customize it. Let's have a look at the answer. Rule that allow outbound, a rule that denies all inbound connection. Okay. Next, you want to evaluate the GCP for PCI compliance. You need to identify Google inherent control. Which document should you review to find the information? Shall we review the GCP customer responsibility matrix? We are talking about PCI compliance. So yeah, not so A is wrong. PCI, DSS requirement and security assessment. Yes, however, this does not provide all the required, compliance information in the PCI SSE Cloud Computing Guidelines. That sounds right to me. And product documentation for compute engine, which is wrong. So the confusion between B and C. However, it's about evaluation PCI compliance requirements. So the answer will be C. Okay, that will give us the guidelines to evaluate, okay, PCI compliance. Next is customer need to prevent attacks from hijacking their domain IP and redirect users to malicious site through man-in-the-middle attack. What solution which will help? Yeah, I want to prevent somebody from domain and IP. Straight away, domain IP, we're talking about DNS Security Extension. So the answer will be C, not VPC, not Cloud Armors, not Cloud Identity Aware. These are sitting on the border, but domain and IP that I'm talking about redirection. So let's we secure our DNS to make sure, like, you know, that will not talking about man in the middle, which means attack is happening behind the VPC and the armor. Yeah? Let's have a look at the answer. The answer is C, DNS extension that will help us to secure our DNS and validate against, our environment. Next is our company using cloud data prog for its Spark and Hadoop's, yeah, jobs. We would like to be able to create, rotate, and destroy semantic encryption key used for persistence disk used by cloud data prog. Keys can be stored in cloud. What should we do? Use cloud key management service to manage the key. Yeah, sounds right. Use cloud key management service to manage the key encryption key. No, I'm worried about my data, man. Use customer supplied encryption key and use supplied encryption key and key encryption key. I will lean toward, the cloud because there was no restriction where to store it. Keys can be stored in the cloud, hence shift the responsibility and workload. So the answer will be A. Yeah, use cloud key management service to manage the data encryption key. Okay. Next, you have an application where the front end is deployed on managed instance group in subnet A and data layer stored in on MySQL engine on a VM on subnet B, and there is a on they're both on the same VPC. A and B hold several other compute engine VMs. You only want to allow 3 front-end application to speak to your back-end SQL on specific port. What shall we do? Configure an ingress firewall rule that allows communication from source IP range of from A with a tag that apply to MySQL engine on that port, or configure ingress firewall rule allow communication from front-end unique service account to unique service account from MySQL. So front-end service account to back-end service account on specific port. Configure tag, apply all instance in A, configure tag, apply to all instances in A and network B. It sounds too complicated. C and D same. And the answer is because you're speaking about ports, so C and D are out of the equation. And if you go to A, you will see source IP target, applied, which is not bad. But however, I want to use the communication via service account to control where and only 3 of them. So the answer is B. Configure ingress firewall rule that allow communication from front-end unique service account to the unique service account of MySQL and control only on these ports. Okay, 3306. Last question for part 2 is which 2 security characteristics are related to the use of VPC peering to connect to VPC networks? Choose 2. Central management of root firewall and VPNs for peer network. Correct. Non-transitive peer network where only direct peer network can communicate. No. Ability to be peering that belong to different Google Cloud. No. Firewall that can be created within a tag from one peer network to another. Yes. Ability to share a specific subnet across peer network. No. So the answer is A and D. That was the last questions we had for part 2. Hopefully you had or you learned something useful and you can provide your feedback. Thank you for watching, and we shall catch up on part 3 of GCP Security Best Practices. Thank you for watching. Goodbye.